Assalamu alaikum, dear students. I hope that everyone is doing well. Welcome to the fourth session of the week. Today we are going to start Unit 4, Partial Fractions. And for today the topics are fraction, resolution of fraction into partial fractions, resolution of an algebraic fraction into partial fractions when denominator consists of non-repeated linear factors. So let's begin with the topic fraction. The quotient of two numbers or algebraic expressions is called fraction. The quotient is indicated by a bar. We write the dividend above the bar and the divisor below the bar. Here are some examples of fraction. That the quotient of two numbers is known as fraction, and here the dividend is 1 and the divisor is 4. Basically, in fraction, the denominator shows that in how many parts a thing is divided. We can see here a chocolate bar which is divided into 4 equal parts. And numerator shows that how many parts are taken away. So one part is taken away. Here we can have some more examples of fraction. That here a circle is divided into 2 parts. So therefore the denominator is 2. Here the circle is divided into 4 parts. Therefore the denominator is 4. And numerator shows that how many parts are colored. Okay, in addition it is said that the quotient of two number is or the quotient of two algebraic expression is also called fraction. So here we can see some algebraic expressions. X square plus 2 divided by x minus 2. It is a fraction with x minus 2 is not equal to 0. Let's see that if x minus 2 is equal to 0, then the fraction is not defined. Because if x minus 2 is equal to 0, so the value of x will be 2, which makes the denominator of the fraction 0. Let's put x, the value of x 2. If we derive from the equation x minus 2 is equal to 0, so if we put x 2, so 2 minus 2 will result in 0. So here the denominator will be 0. So if the denominator will be 0, then the fraction will be not defined. If you write a fraction like 4 upon 0 or 2 upon 0 on your calculator, so you will get math error. Or if we just see it mathematically, so if the denominator will be 0, so it will be not defined then, because the denominator is not defined, it is 0, or it will result in infinity. Okay, let's go ahead now. Next is rational fraction. An expression of the form nx divided by dx. Here n stands for numerator and d stands for denominator. Are polynomials in x with real coefficients and denominator is not equal to 0 is called a rational fraction. Let's simply understand it with the help of example. We can see an example 2 algebraic expression and we can name it as polynomial. So what is polynomial? Poly means many and nomials mean terms. So that type of algebraic expression is known as polynomial, where the variable is raised to the power positive integer. Here we can see that the power of x is positive and it is as well as it is integer. Integer is that number which is complete in itself, which is not in fraction form. So here we can see both of these algebraic expressions are polynomial. So this is known as rational fraction. Moreover, it is said that it must have real coefficients. So real means it should not be imaginary, rather the coefficient should be real number. Next we have proper fraction. A rational fraction with denominator should not be equal to 0 is called a proper fraction if degree of the polynomial nx in the numerator is less than the degree of the polynomial in the denominator. So what is a proper fraction? If the degree of numerator is less than the degree of denominator. Here we can see that the degree of polynomial in numerator is 1 and degree of polynomial in denominator is 2. So this is a proper fraction. If we understand it with the help of numbers, so we can see that numerator is less than the denominator. So this is a proper fraction. Most of the time we get confused in order to tell that whether it is proper fraction or improper fraction. So we can easily remind it like for a proper fraction less and for improper fraction more or greater. Means if proper fraction is stated, so you can just keep in mind that for it less and for improper fraction greater. So here proper fraction numerator is less and improper fraction numerator is greater. Okay, here we have improper fraction now. A rational fraction where denominator is not equal to 0 is called an improper fraction if degree of polynomial means in numerator is greater or equal. It can be equal as well to the degree of the polynomial in the denominator. Okay, here we can see that numerator, and I told you that for improper fraction we have to keep in mind greater. We can see here that the degree of polynomial is greater than degree of polynomial in the denominator. Here you are not going to see the coefficients, rather the power or the degree will finalize or will make the denominator or make the polynomial greater or small. Okay, here we can see that the degree of polynomial in numerator is 1 and degree of polynomial in denominator is also 1. So here this is also an improper fraction because if it is greater or equal. In addition, you can keep in mind that how you can state that this is a improper fraction if the division is if the division is possible. Like you can see that this x4 can be easily divided by x cube, and if it is x and x we can divide it. But if in numerator we will have less, means if the degree of the polynomial will be less, so we cannot divide it because we cannot deal with decimals here in algebraic expression. As you can see, with the help of numbers we can understand it that if the division is easy, like 2 and 2, we can see here it can be divided and we will get 1 without the decimal, without the help of the decimal. Moreover, we can see that 4, if we divide it by 2, so we can easily divide it and we can convert this in improper fraction. So if you don't need the decimal at the beginning, means so it will be improper fraction. Every improper fraction can be reduced by division to the proper fraction. Yes, means we can convert the improper fraction by division to the proper fraction, because in improper fraction we have here the degree more, or we can have the number is greater in the numerator, so therefore the division is possible and we can reduce it into proper fraction. We have another concept here, identity. An identity is an equation which is satisfied by all the values of the variables involved. Here we can see that 2 bracket x plus 1, 2x plus 2. If I multiply 2 with x and 2 with 1, so it means the same thing. So this is known as equation of identity. So equation of identity is that equation which is satisfied by all the values of x. Means if you put any value of the x, either 100, either 1, either 0, 4, up to you. So you will get both the equation satisfied. Here we have put 1, so we can see here that both the sides are same. If you put 2, 3, so again you will get the same answers. So this is known as equation of identity. This concept will be used ahead in the exercise. Okay, now let's come towards the main topic, which is resolution of fraction into partial fractions. Here you can see some fractions: 1 upon 2, 1 upon 2, 1 upon 4 and 3 upon 4. You can see plus sign in between them. When these fractions are added, so we can add it with the help of LCM. We can take 2 common, so 1 plus 1, and as a result we will get 1. If we add it orally, like 1 upon 2 means half, 0.5 and 0.5 will make 1. Moreover, here if we add this by taking LCM, so we will get 1. 1 upon 4 means 0.25 and 3 upon 4 means 0.75. So 0.25 plus 0.75 will make 1. So here these are known as components or partial fractions. When you will see some fractions in between them, if you find addition or subtraction, it means those are the parts or the components of the single fraction. Here we can see this is a single fraction, and this fraction is made up of these parts. So these are known as component or partial fraction, and this is known as the resultant or single fraction. So in this chapter, our basic objective or our main objective is to resolve fraction into partial fractions. And like in class 9 that you were given the single fractions, if you remember in exercise 6.2, you were given these partial fractions or components, and you were supposed to simplify, and you were supposed to bring the answer in resultant fraction or in single fraction. Let's go ahead and you'll get it cleared. Here is the main topic, that resolution of an algebraic fraction. We are not dealing with numbers. This is just for the sake of example or for the sake of concepts. So here we are basically going to deal with algebraic fractions. We are going to resolve it into partial fractions. Algebraic fraction, a single fraction will be given, and we are going to make the parts of it. When denominator, okay, here some means the topic is specified here, that what is the topic, that when denominator consists of non-repeated linear factor. This is very, very important to keep in mind, that what type of denominator that means fraction has. So the denominator is non-repeated, means it is not in repetition, like you can say x plus 2 and x plus 3. There is no x plus 2. Non-repeated linear, linear means the power will be 1. So the denominator will be non-repeated linear factors. Okay, in grade 9 you used to have this type of fractions, and you were supposed to take the LCM, and you were supposed to bring the answer in resultant fraction or in simplified form. Now we have to go with the reverse procedure here in grade 10, that the resultant fraction or the single fraction will be given, and we will be supposed to find the partial fractions here. So here let's understand this concept with the help of example. This is an example here. Here we can see these are the partial fractions. Two fractions are given, and in between we can see plus sign. So we can take the LCM. X plus 2 and x plus 3 are the LCM. The numerator is written. With numerator we will have x plus 3, because x plus 2, x plus 2 will be divided, then plus 3, and with 3 we will get x plus 2 here. Okay, by multiplication we will get this expression, and when it will be added, 2x plus 3x will be 5x, and 6 plus 6 will be 12. So by solving or by addition of these partial fractions, we got a resultant fraction or a single fraction. Now here is the concept, that in this chapter we will be given this single or resultant fraction, this one, and we will be supposed to find these parts of this. So how it can be done, let's understand it with the help of this example. Here we will write this resultant or this single fraction, and we are supposed to find the parts of this. How many means here will be the partial fractions, the denominator will decide. Here we have two factors, so two partial fractions it will have. Here this a shows the constant, or means the value, means this one that we are supposed to find, 2 or 3. So a stands for this, and we will write the denominators as it is x plus 2. Then plus sign, you can see here. Okay, plus sign will come. Then we will be having the second, because it has two factors, so therefore two partial fractions will be. So b, and x plus 3 means this the same. So we can derive it from here. Since it has two factors, so a x divided by x plus 2 plus b x plus 3. We can name it as equation 1 here. Now we are going to solve it in order to find these unknown values a and b, these partial fractions. So we can solve it by multiplying both sides by LCM here, because if the fraction is not eliminated, so we cannot go ahead. So the LCM will be this one, x plus 2 x plus 3. So if we will multiply both sides by the LCM, so it will get cancelled. Then a will come. With a we have x plus 2. So x plus 2 and x plus 2 will get cancelled. And we will have x plus 3 here. Then plus b is written. Then x plus 3 with x plus 3 is cancelled. So what is left? X plus 2 is left. We can name it as equation number 2. Let's solve it ahead now. Okay, here we have resultant fraction, and this we have as resultant fraction and partial fractions. Okay, equation here, a statement is written that equation number 1 is an identity. It's equation number 1. Equation number 1 can be an identity, or we can say equation number 2 is an identity. Equation number 2 is an identity which holds true for all values of x, and hence for x plus 2 is equal to 0. And so if we will find the value of x, it will be x minus 2 and x minus 3. As I told you earlier in the previous concept, that equation of identity means both sides will be equal. Here you can see that this is the resultant fraction and this is the partial fraction. So part makes the whole, so means this both side will be equal. So this and this can be equation of identity, either equation number 1 or equation number 2. And it will be true for all values of x, means if we will put any values of x, so it will satisfy the equation. So but here we will put some particular values which can be derived from the factors, from the denominator. So one of the value of x will be x minus 2 and the other value will be x minus 3. So here we will have two values of x, x minus 2 and x minus 3. We will put these values in the equation, in this equation number 2, in order to find the unknown values a and b. So let's put it here. Instead of, you can see here we have 5, and instead of x we will put means minus 2. Here we have put, then instead of x we will put minus 2, and again instead of x, wherever we will have x we will put minus 2, and by calculation then we will have b0 is 0, it will get means multiplied and it will be 0. So the value of a will be 2. Now next value of x is 3, so again we will put in equation number 2. Now instead of x minus 3 is put, you can see that here was x, so minus 3 and minus 3. As a result we will get now a will be multiplied with 0, so it will be 0, and plus minus minus, and b1 is b. So the value of b will be here 3. Minus and minus will get cancelled. So here we can prove it that by applying this method we can bring this partial fraction. You can see here that 2 divided by x plus 2 and 3 divided by x plus 3, and same we have found the same value of a is equal to 2 and b is equal to 3. So by means following this method we can find the partial fractions. Some points should be noted here, or you have to remember that general method applicable to resolve all rational fractions is as follows. Means if you want to resolve the means resultant fractions into partial fractions, so some points we have to keep in mind. The first one is that the numerator must be of lower degree than the denominator. Numerator, the degree of numerator should be less than the denominator. It means that it should be a proper fraction. Why it should be like this? Because whenever we solve the partial fraction and we get the resultant fraction, so we always reduce the resultant fraction in its simplified form. So therefore that simplified form or that resultant fraction should be in its simplified form. So therefore the numerator should be less than the degree of the denominator. It means it should be proper fraction. So whenever there will be improper fraction, the first thing is that improper fraction should be converted to proper fraction. Next point is, if degree of numerator is greater than the degree of denominator, the division is used and the remainder fraction can be broken in partial fractions. Next is this, that how we can convert the degree of numerator into means smaller degree. It can be done by division. Okay, multiply both sides by the LCM in order to eliminate the fraction. And fourth one is that we have to factorize the denominator. If the denominator will be not in factorized form, in factor form it will, so we have to factorize it. These points you have to keep in mind, but this will be you can learn it easily when you will be in practice of the exercise. So in the next session, inshallah, we'll go with the exercise. So have a nice time for now.